A few videos ago, I started a project on my quad walker project. It was inspired by Kevin McClear's crab design here. The thing that got my attention was he was using this breakout board for the Raspberry Pi PicoW, and I thought that was going to be a really good thing just to have your battery and everything. So we can go to it's this board here, and anyhow, it breaks out a bunch of the pins with for servos and stuff like that, and thought that was going to be great, and got the battery built into it, 18650. Uh, should have been able to get a good bit of at least half hour running it out of it, I would have thought, and everything. But it's got other features. It's got a few neopixels, some buttons. It's got a PZO button buzzer on it, um, and everything. And actually, it has motor drivers. I haven't looked at that yet. Anyhow, it's coming. It came from the um, Far East, so it took the slow boat to get here, and it got here a couple days ago. And I said, "Oh, good, that's pretty cool." So anyhow, on my first video, I showed. Let's see if we can find it. I showed where I was putting the parts together. That's not a very good shot. Oh well. Let's see. There we go. I'm out of the way in that one. So I designed in Fusion 360 the parts to do it, and I had all those printed out and put together. Um, Kevin McClear had different servos, so I had to redesign mine for MG90 servos. I thought would work well on it, and everything. So I've had good luck just using the plastic gear servos in my uh, robot where my walking robot that I've showed off in another video a while back, and I thought, the metal gear might give me a little bit more strength and or a little bit more uh, resistance to braking and everything. Um, I probably got 10 hours on my walking robot and never had any problem with it, so I didn't worry about that too much. But I had the Metal Gear servos in a drawer, so I didn't have to purchase them, so that was good. So anyhow, I did that, got that done, printed it out. Also on this video, I also went through and slow mode a video showing the positions of a commercial product that or a robot that was another video and showing it walking. I'm not sure whether that's a commercial product or not. It might have been, might not have been. But anyhow, um, I came up with a chart of moves and everything for it, and so I was designing that, and uh, I also over the past few months been working with the Wi-Fi side of it of the PicoW, and um, I figured out how to use a slider to control a servo. I also did a video on that. So um, I said, well, I need to figure out what the positions for each of these movements is going to be. So I said, well, the best thing to do with that is put a bunch of sliders on there and connect it up and get this thing working. So we'll go to Thani, and so it took about 100 hours of code and 100 lines of code and 120 lines of code, and um, we have to use HTML, so had to learn something more about that. I had done web pages in the back, but uh, these days hadn't used it for 20 years, so had to renew my how that worked and everything. And we're doing it in the Python, so we're using this formatted string to uh, assemble the code. So we were doing 8 of the same thing for the sliders, for the range sliders. So I used a for loop to uh, do the slider, so that didn't have to keep typing all that over and over again, and just put the different names for the different uh, values and IDs and stuff like that. Everything in a single curly bracket is that. So that's cool. And then also you have to make decisions inside. HTML doesn't make decisions, just a display language. So you have to use JavaScript. So well, I hadn't really played with JavaScript too much, but it's very similar to C++ Arduino code. So um, I had to learn the jargon, but at least I understood the way the setup for like the functions and stuff like that you're doing. One thing, you might see these double curly braces here. So anytime a function in JavaScript is defined by the curly braces, just like in Arduino, but when you're using an F string, you're using the single curly braces to insert variables into your string. So you use double curly braces to say, oh yeah, I want one curly brace there in my code. So you have to use double. That's kind of interesting. Like I said, I just had to figure out what to do with that, but that was cool. And then, like I said, I wanted to, what my purpose was with these 8 sliders was to get these positions and then put them into a JSON file, or it's going to be in JSON format, but it looks like a list when you put it in there, and when you pull it out, it'll be a list. And but I was using this JSON, what is it, JSON.load and JSON.dump to get your to load it from a file called move pos.txt into a list here, Python list. And the first time through, of course, you're not going to have this list. So you have this error thing here, and you create an empty list with all your values of 90. So and it's a list of lists. Each list has 8 values, and then you have one for the body, one for the mid, and one for the stretch positions on them all. And so it was a list of lists, and I create those really like that. And then when you're done with the program, you just save that list to the file. So the next time you want to just all your positions will be saved, but if you want to tweak them, you can come back to this program and tweak them a little bit. So everything was working well, and I had that working. I didn't have the board, so I was just doing like one servo on the breadboard just to make sure that it was working, and I kept changing the pins to make sure things were working with it. And this is our code to create your connection. I went over that in my single servo control video. So it's basically the Raspberry Pi Pico documentation Wi-Fi code with a little twist for what I needed to do. So all that above there was that, and then this is where I pull my information that I need out of the return from the HTML page. It sends the HTML page sends a get, and it looks like this down here. And so we pulled out that it's a slider, and it's for the leg left back, and the position was 74 when we changed it. So that's what this down here means. When we do all the list manipulation, you end up with getting just a list with the 2 items in it, so that you know what you're changing. So anyhow, that was all working well, and I got it working, and I've actually done it. And this actually, like I said, it puts the creates a web page, and you get to do it. So we'll go to the web page now. Just you can see it's just 192.168 and stuff like that. So anyhow, this is the page, and this is, I didn't show off the robot. Let me make this a little bit bigger. So I assembled the robot, and it turned out fairly nice. I don't know how much you can see. I'm just going to use the webcam here, but it's basically what I had, and this is that WuKong thing in there, and got the PicoW right there, so that's where all the information's coming through. I got it powered by the by a power bank, and the bottom one is for the power bank or from a wall wart, and the top one just going into the USB, just so I can tweak the program and upload it again if I want to. But you really don't need that. All you need is power to the Pico, and we could do that, and it would keep on, you know, as long as you're changing things here, it would just adjust it and everything. So anyhow, so I got that working, and I can, let's see, I think this is the front, so you should see this front one move. There you go. There we go. So I said, oh, that's cool. And then this is the left front leg part that goes up and down. That's down, and that's up. And we can also go to do the other one. So I can adjust all four legs just the way I wanted them. So I was actually doing that and holding it up like that. And then I set everything down on my table. And I don't know whether I'm going to be able to see this or not. But I set it down, and I started adjusting them. And all of a sudden, the leg goes up. I'm not sure we're showing that. The leg goes up. I'm not going to be able to show this, but anyhow, the bottom line is that the servos would not pick up the robot. And I said, man, that just doesn't make any sense. This robot's no heavier than our walking robot, and it did a lot more, had a lot more power than that. So I went and I looked. I said, I knew that this thing's being powered by a single LiPo battery, but it goes to 4.2 volts or whatever when it's fully charged, and it's fully charged right now. But the legs will not pick up the robot. And I said, okay, well, I guess 4.2 volts isn't enough. So I went and measured the power on those pins, and it's not the battery voltage on those pins. It's 3.3 volts. And servos are not going to have much juice at 3.3 volts. I can't believe that that's what they decided to make that WuKong 2040 board just have 3.3 volts on the servos. It's not going to power any kind of servos. Like I said, it's got motor controllers on it. I got a feeling they're probably working at 3.3 volts as well. And it's just not enough voltage. That's one thing that I really enjoyed about the Arduino was it's 5 volts, and 5 volts took care of, you know, little hobby motors. They ran really well, and servos, they just, you know, they're designed to work between 5 and 6 volts. You know, they'll go down, you know, 4.5 volts or whatever and still work well. And I got a feeling that they that it just was just a poor design, and the board was like $10. It didn't come with a battery, so I had to put my battery in it. So $10 a piece. I bought 2 of them because I said, well, if I'm going to ship it all the way from Far East, I guess I better get 2 of them. So I dropped $20 on it, but I got a feeling this is pretty much a waste of my money. So this robot, I don't know. I'm gonna put it on the shelf for a while and think about it. I could do something and design my own. I could. I've had good luck using, like I said, on our walking robot. We use just those little round power banks. I don't know whether I have one sitting here or not. I don't see one, but just those little round tubes. A lot of them just had a light on the end of it, and they work really well. I don't still don't see one around. Okay, but anyhow, they but it was 5 volts, and that's they worked the servos. I got a feeling that they probably wouldn't do as well. That walking robot wouldn't have done as well at 3.3 volts either. Probably just not enough juice to make those servos work at all. So I may try to redesign this for using with a power bank so that we're getting the full 5 volts into it. I think that it would work, and it's a neat project, and I got all the parts put together. Um, I actually had a larger servo. I thought I had that sitting here too, but I don't see it. Here it is. So I had a larger servo, and I just hooked it up to, it's like twice the size of the MG servos. I thought, well, that's going to be a lot heavier and everything. Maybe it'll run off of 3.3 and have enough torque to make them move. But 3.3, this thing needs assistance just to make it move. So I I hooked it up to I've had this for an Arduino project, and it works fine. You don't want to run this off your computer because it'll kill your USB port on the computer if you're trying to run it off of that. But if you run it off of a wall wart or a power bank or something, it runs fine at 5 volts, but it wouldn't even turn at 3.3 volts. So I am calling the WuKong 2040 breakout board a total fail for what it's designed for. I guess, like I said, I had it hooked up, and it'll move the servos and everything. If you just want to demonstrate a servo moving, I guess that's fine. But the whole idea was you can control a lot of servos, so you can do a spider bot, or you can do whatever with it, maybe a claw, one of them gripper claws where you're going back and forth. It would not work for that at all. We put those gripper claws together, those ones that are like laser cut plastic, acrylic, and they have a lot of friction in them, and they kind of stressed. You had to make sure you had put together right to make them work on the 5 volt Arduino. And I used to do that with the students at the library. But anyhow, that's probably all I'm going to say. But the WuKong 2040 board, don't buy it. It's not if you want to try using it with servos that need to be powered for any kind of strength. Anyhow, that's all I got for today. Thanks for watching. Have a great day, everybody.